if we look into the course learning outcome, we have 4 CO, right? The first one is the one that we have discussed in the first part of our semester, which is analyze fluid flow problem. Within it, we have the introduction of Navier-Stokes and external flow, right? Within the external flow, you have the boundary layer approach. Okay, so the next now is week 7. So in the next 6 or 5 weeks, we will try to finalize 2 CO. Okay, one is involving compressible flow, and the other one is involving turbo machinery. Okay. So in this chapter, we will first go into the compressible flow. Okay. Now, if we go into the fluid mechanics problem, right? The classification of fluid mechanics. If you remember last time when we are dealing with fluid mechanics, you have fluid static and fluid dynamics. The fluid dynamics can be split into 2, which is kinematics and dynamics. Kinematic is your Bernoulli equation where you don't have any shear stress and so on, right? And the dynamic is when you are dealing with Navier-Stokes, when you have shear, okay? And then in the dynamics itself, you have been involved with the aerodynamics. This is the external flow that we have discussed before, okay? Now, in this chapter, we will go into this gas dynamics, okay? In the last chapter, when we are dealing with the pump, we will deal with the hydrodynamics, okay? So, by end of this fluid mechanics 2, we hope or we expect you to be a complete fluid mechanic engineers, right? So do not come to me again asking, sir, how to calculate the pressure drop in a burst pipe. You need to know how to calculate that. And it happened before, right? I know my students usually hate me during the class, right? Because I give them a very tough test 1, test 2, the failing rate is very high, right? But somehow when they got problem, they come to me. Right? One student even called from KL because he's having internship in CE. She was having internship in Petronas. Then she called me, sir, can you re-explain to me how to calculate the pressure drop when I have a pipe burst? Okay, first I'm happy because she still remember me. Right? Second, I feel sad also because she remember me only when she got a problem. Okay, so anyway, always good to help. So hopefully by end of this fluid mechanics 2, you will be able to handle all those fluid mechanics problems. Okay. Another interesting thing that I would like to highlight here is that in the aerodynamics, you have at least now you have a basic understanding on how to design a wing of aircraft, right? But then we always talk about the engine. Usually we will skip the engine, just choose the engine and that's it. But now we need to know how those engine is working, right? Usually if you have an aircraft nowadays, there are no piston engine used in the aircraft. Even though piston engine is a very efficient engine, right? But it will not have enough thrust that we need to drive the aircraft. So if you look at the aircraft now, if you look the small aircraft, some big aircraft also still using it. They are using the so-called turboprop. This turboprop is a propeller that connected to the turbine. So the turbine will have the shaft, common shaft with the propeller, and the propeller will move, provide the thrust. That's why we call it a turboprop. But the name turbo means it is from this turbo fan, right? A rotating machine. Then you have the other one is the earliest kind of jet engine. We call it a turbojet. Okay, a turbojet is much smaller. It has a higher thrust, but it's very fuel inefficient. This is turbojet. Okay, so the difference is, okay, before we go into that, you have a turbojet. Okay, usually this one all air. Okay, so you have this one is your compressor, right? This one is your compressor. This low pressure compressor will connect to the low pressure turbine, whereas the high pressure compressor will be connected to the high pressure turbine. And here you have the combustion chamber where your fuel will be injected and it will burn, provide the explosion needed to drive the turbine. So this turbine drives the compressor. Okay. In this case, the thrust is provided by the exhaust, the jet. So it is a jet thrust. Okay. This is turbojet. If you do not want to have the turbojet, then you can have the so-called turboprop. What is the difference between turbojet and turboprop is that in this case you have common shaft, right? Common shaft. This one is your compressor, another compressor. Then here you have the turbine. You have another turbine, but this shaft is connected to a propeller. So the intake will be from the side, and the exhaust, because the exhaust is not so powerful compared to that, because the power has been taken by this prop. So usually you can see it's a small exhaust over there. So this one is turboprop. Okay. The nephew of this turboprop is the called turbo shaft. It's the same with the turboprop, but rather than having it in the front, so you take it from here and then you connect with the shaft. Right? So this is your blah 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 blah. Then you connect this, and where you use it, usually it is used for your helicopter. If you are rich, right? You want to travel from Toronto to KL every day, you can do that. You can buy a helicopter, then you will get this engine installed in your helicopter. Okay, now this, and the last one is the so-called turbo fan. This is the one installed in your big aircraft. Why we call it a turbo fan? Because this turbo fan has a big fan in the front. Rather than having a propeller, it has a very big fan. So the one that you see, those aircraft engine, right, is the fan. Okay, so if you see this thing, you will see there is a big fan on it, right? So you can see this is the big fan that you see, right? And then you have a compressor, and then you have the turbine. Okay. Now you may ask, what's the difference between turbojet and turbofan? Okay, the difference is this fan drives the flow, but not all of this will be burned. So it has two layers. This is the turbojet, where your fuel will be burned here, right, producing the thrust. But then over here you have a cool air, unburned. Okay, why unburned? Because if you have a cool air, the density will be higher, right, compared to the hot air. Hot air usually is lighter. So you mix them here, then you provide a much larger thrust while burning a much lesser fuel. Nowadays the ratio is 1:26, and the compression ratio can be as high as 1:46, which means if it is here is 1 atm, after the compressor, inside the burning chamber, inside the combustion chamber, it can be 46 atm. Okay. Right? So this is the difference. Huh? Okay, if you see Boeing 737, this is the engine. Okay, and then if you see the you will see the engine is different. Okay, in the newest aircraft, the engine is bigger. Right, this is your engine, but then for this Boeing the engine is smaller. Okay, because this engine is a turbojet engine. This is turbojet engine, which burns most of the fuel. Whatever air coming in, it will burn, because it will be mixed with the fuel. It will burn. It will produce a thrust. But if you look at the newest engine, most of those air sucked by the engine is not burned. It will just help the thrust at the end. Right? Okay. Basically, some of those old engines, they do some innovative way to increase the thrust by having a spray of water. Because when you spray water, the density will increase, then the thrust will increase. Okay. So now, you have designed the wing. Now we need to look into the engine itself. That's why we are dealing with this, right? Okay. So we will dealing with the gas flow, or the compressible fluid flow.